Hello, everyone, and welcome to this hands-on lab with Tekton. Let me start by sharing. So I think you've got my slides up and running. So you should see the first slide with pre-requirements. If you have just a few minutes, the links are also in the Slack channel. So if you want to take a look at these, if you already have installed Minikube, that would be perfect. There's also the Kubernetes Playground that you can use. So this will spin up a Kubernetes cluster that you can try and use for an hour, I think. And there's also the Tekton command line that you will need. There is also a VS Code extension, which you can install if you'd like to give it a try. But I guess we're ready to get started now. Let me find my slides. So welcome to the hands-on intro to Cloud Native CI/CD with Tekton. My name is Joel Lord. I work as a developer advocate for the Red Hat Openshift platform. And I came to this world with a lot of experience as a software developer. So it was kind of interesting for me to learn about all this CI/CD and everything working inside the Kubernetes cluster. So I really like this Tekton tool, and I'm really happy to talk about it today. And I'll let you introduce yourself, Jen.
All right, great. So I'm Jan Kleinert. I lead the Openshift developer advocacy team at Red Hat, and I'm also really excited to be able to co-present this workshop for all of you today. This is a pretty short time frame for the workshop, and we want to make sure that we have plenty of time for the hands-on exercises. So we'll go ahead and get started. So back over to you, Joel.
Definition. To define CI/CD, I've looked up the Red Hat website and found a following definition, which I thought really encapsulates what it's all about. So CI/CD introduces ongoing automation and continuous monitoring throughout the lifecycle of applications, from the integration and testing phases to delivery and deployment. So the acronym CI/CD has a few different meanings. CI is, or pretty much always refers to continuous integration, which is the automation process for developers. Successful CI means new code changes to an app are regularly built, tested, and merged to a shared repository. So it's a solution to a problem of having too many branches of an app in development once that might conflict with each other. The CD part refers to continuous delivery and or continuous deployment, which are related concepts that sometimes get used interchangeably. Both are about automating further stages of the pipeline, but they are sometimes used separately to illustrate just how much automation is happening. Continuous delivery usually means that developer changes to an application are automatically bug tested and uploaded to a repository, where they can be deployed to a live production environment by the operations team. It's an answer to the problem of poor visibility and communications between dev and business teams. To that end, the purpose of continuous delivery is to ensure that it takes minimal efforts to deploy new code. And I'll let you pick it up from here, Jen.
All right, thanks. So now that we've established what we mean by CI/CD, let's talk about cloud native CI/CD. Cloud native is such an overloaded term, so we'll talk about what we mean by it in this context. So containers, what we mean there is that cloud native CI/CD supports applications that run in containers and that are orchestrated by Kubernetes. It must be serverless, so it needs to be able to run and scale on demand without the need for a central CI engine to be maintained or taken care of. And then finally, DevOps. So what we mean there is that these systems are built with DevOps practices in mind, and they allow teams to own their delivery pipelines alongside the applications without having to rely on like a central center of excellence team that manages delivery pipelines on other teams' behalf. So it kind of gives them that ownership and freedom and flexibility. So really, when it comes down to it with cloud native CI/CD, we want to be able to build, test, stage, deploy, everything, all of that with all of these characteristics in mind. Okay, next slide. Oh, there it is. I'm looking at my own screen. So there's many options available for your projects to choose from. Jenkins, JenkinsX, Spinnaker, you may have heard of these. There's also a lot more. And you could take a look at the Continuous Delivery Foundation. We've got the link there, cd.foundation, to learn about those and more. So the one project that we're going to focus on today, though, is the one with the cutest logo. Tekton is a powerful, flexible open source framework for creating cloud-native CI/CD systems. So it integrates into Kubernetes and allows developers to build, test, and deploy across different cloud providers or on-premises systems. So it gives you a lot of flexibility there. But if we look at all the existing tools, whether it's Tekton or some of the others that we mentioned, they all have a few things in common. So for example, you probably have inputs like your code, you perform some kind of task on that input, and then you have an output, which might be something like an image that can be deployed. So Tekton was built with all of that in mind, right? So it provides us a set of tools that are composable, declarative, reproducible, and cloud native in order to make it easy to build these pipelines. So the way that Tekton does this in such a Kubernetes native way is that it adds a few CRDs or custom resource definitions into your Kubernetes cluster. And then you can use those pieces, those building blocks, to put your CI/CD pipelines together. And now I will turn it over to Joel to talk about that some more.
Take a look at those building blocks that Tekton provides us with. So first there are steps, tasks, and pipelines. So a step is one of those operations that you can perform on your code. So say you're building a Node.js application, it might be running some unit tests. That would be a step. Or validating that the code follows the coding standards that you have in place. That would be another step. So Tekton will perform each step inside a container that you provide. For that Node.js application, you can run a rel-based universal image with Node.js installed on it. So steps are the most basic task or most basic building block in Tekton. Now, a task is a collection of steps. So as you can see in that diagram, we have task A, which is a collection of 3 steps that are performed in order. Tekton runs those tasks inside a Kubernetes pod, which allows you to have a shared environment when you're designing a series of steps that are related. For example, you could mount a volume in a task that would be shared across each step for a specific task. So tasks are specified as custom resources in your Kubernetes cluster. And finally, we have the pipeline. The pipeline is a collection of tasks that can be executed in a number of different ways. In this diagram, the pipeline will start by running task A, then we'll run both task B and C in parallel. And once those 2 tasks are successfully completed, task D will run. Tekton provides developers with a lot of flexibility on how and when those tasks should be executed. You can even specify conditions that a task must run in order to meet in order to trigger the next one. So pipelines are also specified as custom resources in your Kubernetes cluster. So now that you can perform operations, we will need something to operate on. You might want to output something at the end of your pipeline as well. So this is where inputs and outputs will come into play. Each task and pipeline will have their own inputs and outputs. The nice thing about the reusability of Tekton pipelines is that once you write a pipeline for building, testing, packaging an application, you can use that same pipeline with a different input. For example, you could use a Git repository, just like in this example, and on which you would perform a bunch of operations or a bunch of tasks, and then you would output an image at the end, just like in this diagram. You could reuse that exact same pipeline for a different code base if needed. Resources can be many different types. It could be Git repositories, pull requests, images, clusters, storage, cloud events, and a few more. So they're also specified as custom resources. Finally, we have task runs and pipeline runs. As the name implies, there are specific executions. So a task run is a specific execution of a task. You can run tasks outside of a pipeline to help you see the specifics of a single task if you need to. That's what we'll do in a few minutes. And the pipeline run, similarly, is the specific execution of a pipeline. So your task runs and pipeline runs are also what binds together your tasks and pipelines with the resources. So those runs can be triggered manually, as you will see, or on demand by using Tekton triggers. A pipeline describes the activities that take place during the execution via Tekton tasks. So pipeline, however, does not contain the specifics of the Git repository, image repositories, Openshift, and Kubernetes cluster. In order to keep the pipeline decoupled and reusable across environments, these coordinates are provided to the pipeline during execution through pipeline resources. So one could during the execution, provide different sets of pipeline resources to execute the same pipeline against different Git repos. So you can see here an example of such a pipeline where we start or where we build a Java application, and you can reuse that for all of your Java application with different inputs and outputs at the end. And it's up to you, Jen.
Okay, so now that we've kind of introduced these concepts to you, we are going to take a look at what this looks like in practice. So you can go to this URL here to get started. I'll leave this. Oh, no, sorry. Yes, I'm not in control of that. That's right. So you can go to this URL here to open up the tutorial in your browser. It's github.com/joellord/hands-on-tekton here. And once you get up and running, what we're going to do is walk through some simple explanatory examples of what a pipeline and task and things look like, and then we'll move on to a real world example. So Joel, if you could go ahead and stop sharing your screen, I'll switch over to sharing mine for this next part. Okay. All right, so hopefully you can see my screen now, and what I'm going to do is bring up my terminal and then shrink this browser window a little bit so that we can follow along together. Okay. So as we mentioned at the very beginning, there's a few requirements that'll get you set up so that you can follow along with us if you choose. If you already have Anycube, that would be a great option. If you don't, you can go to this. I'm going to open it in a new tab. Katacoda Kubernetes Playground, just to show you what it looks like. You click this orange Start Scenario button, and it's going to spin up a Kubernetes environment for you. It may take a minute if all of you are doing it at the same time. But once you have that up and running, you can work in this top panel that you kind of see grayed out here in the back and execute any of the commands that we're talking about there. And I'm going to close it out so I don't take up any resources. But again, if you have Minikube, that's a good way to go. So you'll also need the TKN command line tool. There's instructions here on how you can go ahead and install that depending on your operating system. Should only take a few seconds. And then optional, you don't need this for what we're doing today. We'll be demonstrating it for you. But if you want to get the VS Code Tekton extension, you can get it from this link. All right. So with TKN installed in some kind of environment, again, and let me just run kubectl version, make sure my cluster's up, looks good. Okay, so the first thing that we're going to do is install Tekton on our cluster. We've gotten this set up for you here with this command that you can run that will install that for us. So I'm just going to copy and paste so that I don't mistype anything. Now, if you are using the Kubernetes Playground and you're on a Windows machine, you may have to do Control-Shift-V in order to paste. So if you find yourself having some trouble, that might be what you need to try. Okay, so that applies a bunch of resources into the cluster. It gets Tekton pipelines installed for us. So the next thing that you'll need to do, if you haven't already, is clone this repository that we're working in and then cd into that hands-on Tekton directory. I am already in there, so we're good to go. Now, what we'll do next is create kind of a hello world task. So as Joel may have mentioned earlier, tasks run, they exist inside of a pod. And you can use these tasks to perform different operations. They can really do many things that may or may not even be related to, building and deploying an application. They're that flexible. But typically you would use them for things like compiling an application or running unit tests. Our task that we're going to use here is simply going to echo out hello world to us. So, this first section that we're going to do here is really kind of getting you used to the concepts in a hello world kind of way, rather than using this as you would with an application, which we'll do at the end. So let me show you over here. I have this 01-hello.yaml file. And you can see, it looks like pretty much any other Kubernetes resource type. So the kind is task. It's got a name of hello. And then there's the spec here, which has the steps for our task. So as Joel mentioned, a task is made up of one or more steps. So our step, same as what you see here, is say hello. We use this Red Hat Universal Base Image, and then we're just running this command here. All right, so let's try it. We've got it set up so that you can copy and paste these. If you're in that hands-on Tekton directory, this should just work for you. But we're running kubectl apply -f and passing in that 01-hello.yaml file. And the message we get back is that that task was created. Next, we're going to run tkn task start to start it. But first, I just wanted to show you tkn task ls, which will give you a listing of any tasks that you've created. So if you forget the name of your task, you can always run that to go back and see what it is. But let's run it. So to run the task, you use tkn task start. We're using the show log flag so that we can see the logs as they are generated. And then you pass in the name of the task, which is hello. So it'll take a minute here while we wait for the logs to come back to us. But what we should see when it completes is that hello world message. And hopefully, if you're following along, you're seeing similar behavior. Got a little bit of slowness here at the moment, but we'll give it a second as it returns. There we go. So now we have our response back, which is hello world, which is what we expected. So what I'm going to do now is stop sharing for a moment and pass it over to Joel. He's going to show you how to add parameters to a task. So I've stopped sharing now.
That I'll take this task that Jan just created, and I'll try to pimp it up just a little bit. So we have a task that says hello world. So let's try to change that, make it a little bit complex. So when you create tasks and pipelines, you'll probably want to pass some parameters to it. It could be things like, we want to run a specific test suite, or we want to use a specific node version. But in this case, we'll just try to enter a person name for who we can say hello to. So as part of my task here, in the spec part of my task, actually, right here, I can add a parameter. And because I have the VS Code extension installed, I'll have a lot of potential auto-completion. So I can automatically add a parameter. I'll give it a name of person. We won't give it a value for now. I'll just give it a description. There it is. It's the name of the person to greet. Then we will add the default value so that we can still output hello world if we want to. And we will specify a string just to make sure, or a type, just to make sure that the users will be providing us with the right type of parameter. One thing that I can see I just forgot was to actually specify that I'm adding a parameter right here. So we now have our parameter, and if I try to execute this, I'll just change our hello world here. So instead of outputting hello world, we will output one of the params, and we'll just use the person parameter. So we'll output the value of this parameter here. So if I go ahead and apply this task, and it should already be as 02-param for you if you clone the repository. And then I can use Tekton again to use on a task. And I will start the hello task. And let's show the logs. Show the log. Now you can see that I'm asked for the value for that parameter. I can say Joel. And in just a few seconds, we should be able to see hello Joel instead of the default hello world that we had. If I leave it empty, I can still use the default value automatically, and the same will be done automatically for you in your Kubernetes cluster if you're not using directly the command line here. All right, so that's nice. So why don't we try to make this a little bit more complex now and add some multiple steps to our operation. So I've told you already, a task can be composed of multiple steps, and they can each share a same environment. So let's add a first task, which will write something into a file. So we'll call this first step write hello, and we will use the same image, so the universal base image from Red Hat. And I can also specify a script. So instead of a single command, I can add a script. I can pipe this in. I'll just create a small bash script. There it is. So I can use a bash script. We will just echo something just so that we can see the progress here. Preparing greeting. Typing is hard. So, and then we will hello our parameter. But instead of just outputting it to the standard out, we'll put this in a text file somewhere. Now we'll sleep 2 seconds just to actually see those steps one after the other, and I will echo done. Now for our say hello task, we will change this a little bit. And here we'll still use, well, actually, let's use a different image. So we'll change that to a Node 14 image. And we will also use a script here. Node 14, we'll use a script. There it is. All right. And let me just copy and paste right here. So what we're doing here is actually taking a different script. So in this case, we're actually running a Node.js script. And we will be reading that file from /tekton/home/hello text. So you can see here that I've used the home folder. So I'll be writing something in that home folder, and then I'll be reading from it in that second step that I'm doing. I can see that I have a few errors. So instead of trying to debug that, oh, actually, I can probably debug it. And there it is. Huh. So I have my task ready now. So I can go ahead and apply this. Actually, you have it as 03 in the demo folder. Now I've reconfigured my hello task again, so I can run Tekton task start hello, and we will show the logs again, show log. There it is. So I can use let's use Jan this time. There you go. Hello, Jan. So now what is happening is that we have that first bash script that will be running. It will start by telling us it's preparing the greeting, it's writing to a file, now it's done. And we can see that we have our second step right here, and we can see how they are, we can see the name of the step, and we can see the actual output. So they are now sharing this shared volume, so you can write some things in a single step and read from it as long as they're all inside the same task. And I'll stop sharing and back to you, Jen.
Okay. All right. So I'm back here. I actually was following along with Joel, and I'm waiting for my logs to be available here. So I'll give it a second, and then if it's taking a minute, I'll just stop that and we'll move on. What we're going to cover next is pipelines. So we've talked about tasks now. You've talked about how you can add multiple steps into a task, deal with parameters. But many times you're not going to just have one task. And pipelines, what they really do is give us that opportunity to have multiple tasks run to accomplish whatever it is that you're trying to do. So let's start by doing some kind of really generic task that's going to echo in whatever it receives from its parameters. So parameters are say what, which is what we should say. And then there's this pause duration for how long to wait before, providing that response back. We're going to use that task in order to build our pipeline. So you can see here that the name of this task is say something, and that's important because we're going to refer to that say something task in our pipeline by its name. So when we look at the pipeline here, and I'll pull it up in VS Code so that you can see it a little bit better. So here's our tasks. The one that we were looking at over here, the say something task with our say what and pause duration parameters. And then the step here is going to echo out. It's going to sleep for however long we gave it of a duration and then echo out whatever you told it to say. So then our pipeline is here. And so pipeline also has a name, and then it is made up of tasks. So in this case, 2 tasks. Our first task takes in, we give it a pause duration of 2, and then we say what it's going to say is hello, this is the first task. And the second one is going to say, and this is the second task. So fairly straightforward. We're going to use that task multiple times, but use it in different ways with different input parameters. So let's try it out. We'll minimize here. I don't trust myself to live code today, so that's why I'm showing it to you that way instead. So tkn pipeline start, say things, and we'll do show log. Whoop, show dash log. Spelled it wrong again. So no dash there, just show log. Okay, right? Because we didn't actually apply these YAML files yet. So let's do that first. Got a little ahead of myself. But first, we need to apply the task, create those, and now we can create that pipeline. And now we'll be able to run it. So just to repeat what he said before, if we do tkn task ls, you'll see the tasks that we have, and then tkn pipeline ls does the same thing for pipelines. All right. So now if we go back and run tkn pipeline start, say things, it should know about this pipeline now. It exists. All right. So now that's running for us. So let's wait and see what the output looks like before we move on to talking about the different ways. Okay, so this is interesting. This may look like yours, or yours might be different. But in my case, the second task is actually the one that output first, followed by the first task. This happens sometimes. The reason that it happens is that Tekton tries to start them all at the same time so they can run in parallel. But if you need more control, if you need it to be the case that one thing doesn't start running until another thing finishes because you have those types of dependencies, that's when you can use this run after parameter that we talk about in the tutorial. So let's look at how we can modify this pipeline to run these tasks in order, but also to add in 2 tasks that run in parallel and then some other tasks that run sequentially. Because that mimics more closely what you might actually have in a real life situation. So we will go to VS Code once more and look at this pipeline. I'm going to minimize this so we can see a little bit better. I'll make this bigger. All right. So for our say things in order pipeline, again, we're still referring back to our say something task several times, 4 times in fact. So we have 4 tasks in the pipeline now. We've named them first task, second task, third task, and fourth task. And here's how they're set up. So this first one is very similar to what we had before. We're giving it the pause duration of 2. It says, hello, this is the first task. But then here's what we have different. For our second task here, it's going to say happening after task 1 in parallel with task 3. And task 3 is saying happening after task 1 in parallel with task 2. And the way that we make that work is we use the run after field here. And for both the second and the third task, we're saying run after the first task. See here, run after first task, run after first task. So that means neither task 2 nor task 3 will be started until the first one completes. And they will be executing in parallel. And then finally, we have a fourth task, which says happening after task 2 and 3, that has a run after set to second task and third task. So this one, the fourth task, will not execute until both task 2 and task 3 are complete. Okay, so let's see if it behaves like we've set it up. Back to the terminal. I'm going to do it clear so that you can all see my screen maybe a little bit better. So that 06 pipeline order file we were just looking at, let's apply that. Okay. Should see that new pipeline exists now right here, say things in order, so that's good. Don't need any new tasks since we're using the task we had already used in the past. So now we'll do tkn pipeline start, say things in order, spelled it wrong, order, and we'll do show log. If we set that up correctly, we should see the first task, then we should see 2 and 3 start, and then when they're done, we should see the fourth one. So here we go. Hello, this is the first task. Now this third and second one are running. We didn't specify a specific order for 2 and 3, so we kind of just get whatever happens. And then there's the fourth task, which happened after those two completed. So that's just a very quick way of showing how you can have within a pipeline, some tasks can run sequentially, others can run in parallel, and you have a lot of control over how to set that up and specify when things should run. All right, so at this point, I'm going to stop sharing my screen and hand it back over to Joel to talk a little bit about resources.
Perfect, thank you, Jan. Just before I move on to resources, once again, I have the Tekton extension that is installed in, and I'm using VS Code right here. And just to kind of show a little bit what Jan just presented, I thought it would be interesting to introduce the VS Code extension quickly at this point. So right here, you have the Tekton pipeline, and you can see that I have access to all the different pipelines that I have in my cluster, all the different tasks that we've created so far, as well as a few that I already had. so you can see everything in there very quickly. But the one feature that is very interesting that I wanted to show you is the pipeline preview here. So you can see right here that you have the first task running, followed by both the second and the third in parallel. And then finally, you had the fourth task, which would only happen if all of the previous three tasks were successful. So it's a very visual way to kind of see all those different tasks and those pipelines, especially when they're getting a little bit more complex. All right, so I'll move on to the next part, and I want to introduce resources now. So we've already said that pipelines can do multiple operations, but really what they do is that they will typically perform something on either an input, and then they will perform something on an input, and typically they would provide us with an output. So we can go to the pipeline resource example. And you can see here that I have a task that will count the file. So it'll just take a Git repository as an input, and it will just count the number of files inside that Git repository. So you can see here in my spec that I have a resource section, and I have one input. And here I'm telling, well, the name for this input will be repo. It'll be an input of type Git, so it could be multiple things, as I've mentioned in the introduction. And our target path, where will our Git repository get cloned, will be in the code folder. Now for my task, my first step is to count. So I'm giving it the name count. I'm using the rel universal base image again. I'm using a bash script, and I'll just echo the number of files in that repository. Now I'll move on to create my actual pipeline. So the pipeline will have a single task, and it will take a resource as an input. So it'll be the Git repository. I'll give it the task count task, or I'll name my task count task, and I'll give it the files to be run. So this is in reference to the task that I've just created right here. And now I have my input, so everything should be good. And finally, I'll need to actually create that resource. So I'll create a new object of kind pipeline resource. The name for this will be Git repo, which is the same as we have right here. And it will be a Git repository. And the default value will be the actual Git repository you're using for these examples right here. So why don't I go ahead and apply this. And this is the demo 07 pipeline resource. So you can see that everything was configured. So now if I try tkn pipeline, which one was it? How did I call it? I forgot. All right, it was called count. So tkn pipeline count. Start. And let's show log. Show log. I'll get there eventually. tkn pipeline start. There it is. Okay, so now you can see that I have the option to pick different different resources. So in here I have the Git repo that is already created for me, or I could create a new Git resource if I wanted. So if you wanted to run this exact same pipeline on a different Git repository to count the number of files in that repository, you could create a new Git resource here. Well, let's go ahead and use the default one. And I forgot the show log parameter, but you can see that we get this useful logs and the name of the actual pipeline run here. So I can run this command. You can see that my Git repo was cloned. So we can see successfully cloned here. And then I have my task that was performed on it and the actual count of the file and the output that I specified in my bash script right here. So I can see that I have 59 files in this Git repository, which is a lot. It doesn't seem like that much, actually, when I look at my file explorer right here. All right, so those are nice. We saw a lot of different examples. We've seen different ways to share resources. We saw different ways to perform tasks, operations, and so on. There's another thing that I forgot to mention about pipeline resources is that they're still in alpha. So Tekton just released the beta version just a few months ago, but pipeline resources are still alpha. The core team still questions whether they should stay in the spec or not. In the latest version of Tekton, they also introduced workspaces. So those are added to share file systems between the different tasks of a pipeline. So I've shown you how to share a file system between the different steps of a task, but you can also use workspaces to share file systems between the different tasks. I've added an example here, and we can take a quick look at it because I think we still have plenty of time. Yeah, perfect. So in my workspace example, you can see here that I created a persistent volume. So it's a little bit more lengthy to actually use workspaces, but if you're familiar with Kubernetes, this should be fairly straightforward. So first we start by creating a persistent volume, then we start a persistent volume claim just to get this persistent volume, and I'll give it a name. And then in my task, I can specify different workspaces to use. So in this case, I'm specifying the workspace that we'll call output. And I can use that output as with a string extrapolation right here. So I'm using here, I'm telling my task to echo hello into the workspace.output.path. So instead of using the home folder that I used in the previous example, I'm actually using the workspace here. The other task does pretty much the same thing as we did earlier. So it just reads the output of that file, or just gives us the output of that file. So we can see that we're actually reading from the workspace again. In our pipeline definition, this is where we will specify the pipeline that we want to use. In each one of our tasks, we'll also need to specify the pipeline to be used, or the workspace to be used inside this task. So we can see it in the read task as well. And of course, I'm making sure that I'm running the read task right after the write one. If I go ahead and apply this, this one doesn't have a number. It's just called workspace. Perfect. And the pipeline is workspaces test. I can use tkn pipeline start show log. There's an extra slash here that I don't need. That should work. So I'll give it a name, pipeline workspace. And I'll just use the default. And well, this didn't seem like it worked. Actually, I shouldn't be using a empty directory. Let's just try this again. We'll be using a PVC, and the name of my PVC was tkn PVC. All right. So workspaces are not fully working yet. They're a little bit more complex to use than resources are. And I can't figure out, I think it's my subpath right here. So they are there in the spec. They're still pretty much in alpha as well. So sharing different resources between the different tasks in a pipeline is still in alpha mode, but most of the rest that we've shown you today is in beta and should change that much. All right, so that was a lot of content that we've seen so far, but none of that really makes sense, right? You're probably not gonna echo hello world in your pipeline. What we wanna do here is CI/CD. So what we really wanna do is to take a Git repository, perform some operations on it, and then provide us with an image that we can use inside of our Kubernetes cluster. So what I'll try to do here is to look at a pipeline. And in this section, I'll have a pipeline that will use a Node.js project. It will run a linter to make sure that we don't have any linting issues so that the code follows the coding standard of our code base. Also runs unit tests to validate that the code is working. And if both the linting and the testing pass, it will create a Node.js image, push that to Docker using S2I, and build it. So the first thing that we will do is to actually, I'll just go and jump into my real world example here. And we can take a look at our pipeline preview once again. So we can see it does the linting, then the testing, and finally it will build and deploy that image using S2I. All right, so the first task will be to run npm and this first task will do an npm install followed by a linting process. So we can start by creating an object of type kind. We will have various parameters. So the first thing will be the path to the application inside Git. So say you have a Git repository that has the application in a specific folder. In this case, we have an application in the app folder. So I'll want to be able to specify that as a parameter. Secondly, we'll have an action, which will be another parameter. What's the operation that we want to perform by npm? So the default one will be start. And we will have here our first step, which will be the npm install, and we'll use the Git repository resource here. We'll have our npm install, which will run on a node 14 image, and it will run a bash command. So we will cd into the repository / the path context. That was one of our parameter right here. So it specified dot as default, but it will be app in our context. And then it will run npm install. And the second step, I call it npm lint here. But you can see that I'm using the action that was passed as a parameter. So it will actually run npm lint or npm run lint in this case. The second task will be an S2I task. So it will actually take a repository and build an image out of it. So it will take a bunch of different parameters. So it'll take a username, a password from Docker Hub. I will need a image name as well. To create, we will use a registry. In this case, we'll use docker.io as a image name. In order to perform this task, we'll have multiple steps. So we'll have a generate step, which we'll use S2I. We will then build that image using an image that we take from Quaid in this case. And then we will push that image to Docker Hub. We'll have a shared volume between all of those different tasks in here. So you can see how to mount a volume as well. And finally, we have our pipeline. So our pipeline will take all of those different parameters that we need. So first of all, the username, then the password for Docker Hub, as well as an image name to produce. I will have the one resource. I'll have an input right here. And then I have all of my tasks. So first of all, my linting. The second one will be the testing. So I'm reusing that same task that I've created in the first part right here. So you can see the task reference is npm, so it's the same task, but in this case, I'm using run test instead of run lint. So you can see how you can reuse those different tasks as part of the same pipeline here. And finally, we have our build and deploy task, which will take care of creating that image at the end. And of course, we will run it after lint and test. Okay, so first thing I'll need is to actually find my Docker Hub password. So just bear with me for 1 second and I'll leave that out of the screen if you don't mind. All right, there it is. In Docker Hub, you can actually use API keys as a password, which is very useful. Actually, why don't I show it to you? So in Docker Hub, you can create a new access token right here. We'll call it KubeCon. And this is my personal password, which I probably shouldn't share with everyone, but I'll remove it as soon as we're done right here. So if I go ahead and apply this file, kubectl apply demo/08. So we have our real world example. Now I'm ready to start this with tkn. The name of the pipeline was app deploy. First, I'll need to specify pipeline, app deploy, and start. And pipeline start app deploy. I have a hard time putting those in order. For some reason, it doesn't make sense in my brain, but there we go. Okay, so we're using the same repository here. The parameter for user will be Joel Lord, which is my Docker Hub username. My password is the one that I've just copied from Docker Hub. The image name will be kubecon. And let's see, and let's take a look at those logs right here. All right, so we can see that it already cloned my repository, successfully initialized. So far, doing good. Actually nervous to see if this will actually work. All right, so we have our linting that just worked. We have our testing. We can see that our tests passed. Seems like the linting also passed. We went really fast, so that's good. Let's see if it can actually create that image now. So we'll just wait a few seconds. This process can be just a little bit longer, but you can see that it's going on right now. So it's creating our Docker file, and now I believe it's actually pushing that Docker file and it's building it. All right, storing signatures. We're getting closer and closer. Let's see if we can actually deploy an application today. Well, not deploy because it'll be on Docker Hub, but we're getting close. All right, copying all the files. So now we can see our Docker file being processed. This is actually a long time for standing in front of a laptop, not talking, just for listening at the silence. So it's almost ready. Let's give it a few more seconds. It's still building right here. Right, now pushing. So we're just copying everything over to Docker Hub. Now, once this is done, of course, this will be simply deployed on Docker Hub as the latest image. Now, you can add different things to your pipeline as well. So if you're using Openshift, for example, you could use OC to take that image and then send that to your cluster as well. So we're not fully done. We're not fully deployed here yet, but you can see here that my image was actually pushed just a few seconds ago to my Docker Hub. To my Docker Hub. So my image was, so we took our code, we've deployed it, tested it, deployed it into Docker Hub now. So in theory, I could now do another operation to deploy that into my Kubernetes cluster. Just to see that this actually works, what if I would actually go ahead and I'll just go to my code here. And it's a simple API that just adds numbers, right? So it just adds whatever two numbers that were passed in. Let's say I just changed the result intentionally. I'll do return +3 here. Now in theory, and I haven't checked this code today, but in theory, this should not work because now it won't be returning 4, it will return 7. So if I try to run this task or this pipeline again, I'll use the same defaults. I'll need my password again. So please bear with me as I try to find it. Of course, I keep losing where that one is. Security. There it is. I should have copied it somewhere. Actually, I think it's right here. And of course, Jen, please remind me to delete that API key at the end of our session. All right, and the name of the image will be KubeCon again. So now what will happen is that I will be running the application. it will, of course, I forgot to do a git commit new changes, git push origin master. There you go. All right, well, so what you should see now in theory is that it will actually try to run this test. It will fail the test, and it will stop right there. So it won't actually deploy the application to Docker Hub just because one of the tasks fell before the actual deployment one. So I think I've pretty much covered the real-life example as well. You have all of these code samples inside our GitHub repository, which we will share again towards the end. Jenna, you want to take it from here?
So one thing I did want to share at the very end of that repo, let me scroll down before I share my screen. Okay, so down here at the bottom, we do have a few links. One is to tekton.dev, which is just the main Tekton website. There's a lot of great information there. The second link I think is really cool. So this is a preview version of Tekton Hub, which is kind of a catalog of reusable tasks and pipelines that you can use. We're going to do Q&A in a minute. And I did see a question come through asking, I believe, something about like what other options are there for building images other than S2I, because this person had some legacy Docker files. You can find things like that on Tekton Hub. So I'll flip over there in just a second, but there's also a link to this CI/CD and Tekton page on developers.redhat.com, which has a lot of good information, some links to other tutorials and things like that. But this is the Tekton Hub, I have it filtered right now, that I was referring to, where you can find tasks and pipelines that you can use. So if you created something that you think would be useful for a lot of other people, you can also share it. But to answer this person's specific question, if you filter here for image build, you can find a bunch of options. So if you're using build packs, there's an option for build packs there. This is the S2I one that we were using. But to show you what that would look like when you click on it, you can click install, and it will give you that kubectl apply command that you need in order to be able to use that task. And then there's usually also some good information documentation on how to use it. So this is a really valuable resource that I think was only launched in beta maybe last week. So it's pretty new and is a great catalog to look at. So just want to make sure you all saw those resources too. And I'm going to stop sharing my screen so that Joel and I can do Q&A with the time we have remaining. Okay.
Perfect.
All right. So Joel, I'll remind you now, and then again when we're done, don't forget to delete your API key.
I'll do that right away, actually.
Q&A number one. Okay. While you're doing that, I sorted through some of the questions while Joel was doing the last section, and I tried to enter answers, hopefully made them public for some of the questions that are there. I will run through a couple of those now. Someone had asked what Slack channel we're going to be in after this. It is the so #2-kubecon-CICD, and that's in the CNCF Slack. So that is where you'll find us in the CICD track channel in Slack. That's a mouthful. So if any questions we don't get through now or any questions that you think of later, we'll be hanging around in there for a bit after this and checking back in on it over the next few days. Someone else asked for the GitHub URL. I posted it as an answer to one of these questions, but again, it was github.com/joellord/hands-on-tekton. And then the other kind of administrative question was asking how to get the slides. Either Joel or I will share a link to those on Twitter sometime later today. So if you follow us on there, you'll be able to get those. And I put our Twitter handles in the links to one of these questions as well. So let's look at some of the more, topic specific stuff. Joel, if it's cool with you, I can kind of read through and we can just tag team if we know that. Oops.
Sure.
Oh, sorry. I'll look at the camera. I'm looking at my other screen here. Realize you're looking at my ear instead of my face. So I'll go through and read, and then we can figure out ones we can answer now versus things we might need to research and follow up on. But let's see. So one question here. So sometimes you need inputs from the infrastructure or platform provisioning and configuration. How would you work with that in a way that's as non-manual as possible? So let's say if you needed to make sure like something had been provisioned in your platform before moving on, or something that needed to be an input.
I'm not fully sure if I understand the question, but because what we did here was to use the Tekton CLI a lot. The other way to use it would be to you either use triggers and pre-configure all of those inputs and so on. So maybe that's because in our examples, we had to manually enter all of our parameters here, but that's because we were using the CLI. But if you use different things like Tekton triggers, for example, you'd be able to pre-configure those parameters, and it would take them automatically. So I'm not sure if that actually answered the question or not.
That's a good idea. Yeah, we didn't mention triggers much, but that opens up a whole another set of like potential automation that you can do. So that would be good for this person to look at here.
But very quickly, Tekton triggers will just use the GitHub webhooks, or any webhook essentially, and it will just create a task run or a pipeline run for you automatically behind the scene. So you have a little bit of configuration to do, and you can look up Tekton triggers, but that's pretty much what it does.
Okay, the next question. I think we ended up answering this one as the tutorial went on, but there was a question about, can steps run in parallel or all sequential? We did definitely walk through a process where we showed them doing both. So depending on if you can use run after, if you want to make sure that something is completed before you move on. But otherwise, if you have two tasks, they would try to run in parallel.
Tasks will run in parallel or sequential as you want them to run. Steps though will be sequential. So steps inside of a task will be one after the other. But if you need to run more than one, then you could probably rely on multiple tasks and have them run in parallel.
Good call. And I realize now that I was saying steps and thinking tasks in my mind, so I'm glad you are paying better attention to what I was saying than I was. Good point. Can you share the same container across steps in the same task? I'm trying to...
That's a good question. I don't want to speak too fast. No, I don't believe that the container will be shared, but there is some workspace that is shared between the steps in the same task. So that's kind of what we did in the multiple steps, where we wrote into the home folder, and then the second container was able to pick it up. So those will be shared as a shared volume. But I don't believe the actual container can be shared across multiple steps. So it will be a new container every time. I think. Yeah.
Okay. And I think so too, but we can always, if whoever has asked that question pops into Slack, we can confirm in there. Next question was, what happens to the image after the completion of tasks? I mean, in your real world example, you ended up pushing the image, right? So that's one thing you can do with it, but are there any other scenarios you can think of that are worth mentioning?
Exactly. It's up to you to do what you want to do with it. Once it's completed, it will actually remove everything, just like any container, right? Once it's deleted, it will just destroy everything else with it. So you actually need to do something with your image. So in my case, I was pushing that to Docker Hub. You could push that into your current workflow or into your Kubernetes cluster. You can actually have one of the different types of resources is actually a cluster. So you could put in a cluster there as a resource, and then put in your image, your end image, or your output image inside that cluster, if it's not the same one that runs your Tekton pipelines.
Okay. Well, let's see. Next question here. Is there a way of using secrets in tasks? And this is similar to another question that was asking if you could pass in parameters via a file or something like that. So we did a lot of things on the command line. What are the other options that are available for things like secrets or parameters?
No, just always paste it in front of 500 people. That's publicly posting your password. That definitely works. No, you can also use. I can't remember the name of the resource, but you can use Kubernetes the same way you would use in any other Kubernetes to share your secrets there.
Okay, like config maps or
config maps. Thank you.
Yeah. Okay. I wasn't actually sure if that was the answer, so I was waiting to see what you said. Okay, let's see. We do still have a few more minutes, so I'll look at some of these other ones that were marked in here. Let's see. That's similar to the other question about can steps run in parallel that we already answered.
I can take a look at Slack as well. I see that there's a few questions. Let's see. That one was there. A lot of people are actually answering. One of our colleagues, Natalie, is there answering many questions I can see. So thanks, Natalie. That's very nice.
Natalie. Here's one. So someone asked a question if it's possible to have a view like the one with the VS Code plugin while the pipeline is running. One thing we didn't really talk about at all because we were using Minikube and just kind of vanilla Kubernetes here, but on Openshift, there is something called Openshift Pipelines, which is basically kind of like built upon Tekton. And part of what it offers is a graphic dashboard visualization of pipelines and tasks and pipeline runs and all of this. So that is one way that you can do that if you happen to be using Openshift. The VS Code plugin shows you a lot of what's going on, and I don't even know what all the future plans are for it, other than what we saw today.
Yeah, the VS Code is definitely my favorite tool when you're dealing with Tekton tasks. There's a lot of visual representations, and it's very easy to see everything that you have running in your cluster, so you can actually dig into it. It'll actually show you the code for each one of those pipelines or tasks and so on. So it's a relatively simple tool ultimately, but it provides you with a lot of information in a very useful way. So I really like to use that one.
All right, let's see. Oh, we answered that one. There's a lot of questions, so I'm scrolling through page by page here to see the ones that we haven't already answered.
I see a question on Slack, and I don't know the answer to that one actually, but maybe you do, Jen. So should the completed pods be getting cleaned up? Is there a property that governs the retention policy? Because it is true that you will see that you have all of your completed pods if you do a kubectl get pods. They all show up as being completed, but I'm not sure if there's a way to clean them up or if they automatically get cleaned up after a while.
That's a great question. I just ran kubectl get pods myself here and see the same thing. I don't know, but we can try to look into that and follow up in Slack because that's a good question. I'm not sure.
Perfect. We'll take a look.
Okay, cool. Okay, here's a good question. What happens when the pipeline fails? How would you notify the developers? We know if something failed because we're sitting there running the command on the command line. But let's say you had this automated in some way, or the actual developers weren't the ones kicking this off. Are triggers an option there, or would you typically build this into some other existing pipeline framework that you have within your organization?
Yeah, that's a good question. I'm not sure about that one as well. Because I'm using OpenShift most of the time, right? The dashboard right there is very useful. So you can actually have a very, a graphical view of everything and how it's going on. So I'm not, I'm not fully sure on how to actually, I guess you could use conditions to see what's going on and to create alerts based on what happened. If a task failed for some reason, then you could probably use a condition to send an email to an admin or to your developer team. So there are ways where you could do that as part of your pipeline. I guess that is one way that I can see, or just using a dashboard.
Yeah. And you do still have the logs, but again, that requires somebody to think to go check it. So it doesn't quite solve the notification aspect.
Fair enough.
Let's see. How do you... Oh, no, I think we answered that one. Sorry about that.
I have, when you create a Tekton S2I, will that run on Openshift the same?
Will it run the same as it did on like Minikube, for example?
Yeah, that's how I understand it.
Correctly, it should. Tasks and pipelines should basically operate the same on any Kubernetes cluster. Like it shouldn't run differently or do something differently from one cluster, one distribution of Kubernetes to another. And S2I works on, S2I is not, as we saw here, is not OpenShift specific either. So I think it should be the same, but it's possible I'm not fully understanding
that's
the question.
Question by Stuart on Slack. So if you have any, if we didn't answer, please feel free to follow up on that question. But as far as I can tell, all the examples that we've shown, at least today, they do work on both OpenShift and vanilla Kubernetes.
Well, this is a fun question, Joel, but somebody wanted to know what font you're using, and I think they meant in your terminal. If you happen to know, there's some love for whatever font you were using.
I don't know it by heart, but because I tend to do a fair amount of presentations, I like to have fonts that are relatively readable. So let me take a look. Preferences. Space Mono, and it's an open source font. So, or maybe, yeah, some sort of open license at least. So Space Mono is the one that I'm using.
Cool. Someone asked about what VS Code extension you were using to get the YAML linting or the YAML, syntax feedback at the bottom of the window. Is that the YAML extension that's listed by Red Hat, or do you have a separate, different one?
I believe that and that's the thing with VS Code, you end up with so many extensions that you're not sure which one is doing what. But I believe, let me check if I have a YAML extension. No, I don't have one. So it was either the Kubernetes application or extension, or the pipeline one would probably be the one doing it as well. So I believe the one that I had when I had. Yeah, I believe that was the pipeline one that was showing me that error earlier.
Okay, cool. Let's see, most of these are different flavors of questions we've answered already. Okay. You may have answered this, so if so, just let me know. If I feel the need to have a pipeline, I could just have multiple steps in a task. So what would be the situation that I should go and write a pipeline with pipeline resources? So I guess why not just put a whole bunch of stuff in a big task is the question here.
Yeah, that's a very good question, actually. The main reason for using a pipeline over a task is reusability. So in the one example that I've shown, and maybe I can go back to it quickly. There it is. And let's just remove Slack from there. Yeah, I was paying attention. In the real world example, and I went relatively quickly on this one, but you can see that I've created one task here, which is, and if you're familiar with Node.js, you'll see a lot of this. Like NPM is a tool that you use all the time when building applications with Node.js. So you use it for performing just about anything that you want on your application. So to run your tests, to do your linting, to install some dependencies. So you always end up using that exact same tool. So what I did here is one task that is called npm, and then I can share that either through the Tekton hub or to my whole team or to various places. And then anyone creating a pipeline can actually reuse that same task, and just instead of using the default start, can actually use it in different ways. So in my pipeline, if I go back to the actual pipeline, you can see that I have two tasks right here. The first two. The first one is called lint, and the second one is called test. they're both using that same task. The only difference being that the action that they are performing is run test in one case and run lint in the other case. So I'm reusing that same task, so I don't have to rewrite a full task each time. So there's a lot of reusability that you can do right there.
All right. So we have about 5 minutes left. So we'll do maybe a couple more questions, and then we'll head over to Slack. And feel free to drop questions there that we can answer later if you can't do that now.
We'll also be at the Red Hat booth, I think, just to hang out a little bit. And Twitter is always a great way to find me, at least for if you have any questions or follow-ups. Joel with 2_ Lord, and I believe it's at the end of the GitHub repo, or maybe at the beginning. I can somewhere in the GitHub repo.
I think it's in there somewhere. If it's not, we'll add it. Let's see. See if there's one more standout question here. Is there a way to skip a task under certain conditions? So you mentioned conditionals a little bit. Is that something you can set up?
That's a good question. I should definitely look into that. I haven't played a lot with conditions. Yeah, when I tried it, it didn't seem to work very well, but that was a few months ago. And Tekton evolves very, very quickly, so it might be a little bit easier to use now. It's definitely something that I want to dig into a little bit more, so I'm not sure if it could do such a thing. So I'm sorry I can't answer that question, but I'll definitely try to follow up. So in Slack, just ping me, whoever asked that question, and I'll try to follow up today.
All right. Cool. So let's start. There's so many questions. We'll never be able to get all of them here. So I'm sorry about that. We had about 11, like over 100 questions. So thank you all, first of all, for all the questions and for following along with us. Once more, the Slack channel that we'll be in is 2-kubecon-CICD over in the CNCF Slack. There is also a 6-KubeCon-Red Hat Slack channel. And within the event platform, if you go to, I don't have it open right now, so I can't tell you exactly, but I think it's the sponsor showcase under the first link there. I think it's Diamond sponsorship. You'll find the Red Hat booth. We have a message board in there, as well as a bunch of other resources, tutorials, demo videos. I think you can get some kind of virtual swag. So you'll find us over there as well. But thank you, everybody, so much for your time.
Perfect. Thank you very much.